Okay, we're going to use the law of sines on this one. And this one's a little bit involved. We got a balloonist directly above a straight road, 1.5 miles long, that joins two villages. So let's draw the road. Make that 1.5 miles. And the balloon is somewhere above that. And it's two villages. Okay, it says she finds that the town closer to her, we'll say it's this one, doesn't matter which side we go, is at an angle of depression of 35 degrees. Okay, so that means from the balloon we go down 35 degrees to view the town, and these angles here are the same. So that means this angle is 35. Likewise, on the other side, the depression is 31 degrees. So we've got 31 degrees on that side. Okay. Now, to use the law of sines, we need a pair, an angle side pair. Well, we don't have that right now, but we can figure out this angle because we know the three angles on the inside have to equal 180. So if we subtract the 35 and the 31, we see that this has to be a 114 degree angle. So that means, using the law of sines, sine of 114 over 1.5 equals, let's do this pair, 31, and let's find this side here. Sine 31 degrees over x. Okay. So if we cross multiply, we have x times sine 114 equals 1.5 sine of 31. So let's see, sine of 114 is about 0.914. Oops, sorry. So we have 0.914x. Then 1.5 sine of 31 is about 0.773. Which makes our x about 0.845. Okay, so that tells us, let's go back up to our picture. That tells us this is 0.845. Okay. Now the question asked, how high is the balloon off the ground? So what I need to do is then go straight down through here. Okay, and that gives us a new triangle to work with. So let's come down here and just draw the left side of this picture. Okay. We know that this is 35 degrees. Now this whole angle at the top was 114. It's not necessarily split in half, but we can figure out this angle because we know that these two have to add up to 90 because this is already 90. So that would be 55 degrees. Okay. And we just calculated above that this is 0.845. And we're trying to find out this distance here, this length. We'll call that L. Okay? So we actually really didn't need the 55, but it's good to know that those add up to 180. So let's see what we have. We've got 35 degree angle here. We've got the opposite, and we've got the hypotenuse. So this is the sine. So we're going to have sine 35 degrees equaling opposite L over hypotenuse, 0.845. So we multiply both sides by 0.845. We get L is 0.845 times sine 35. So that gives us about 0.485. So that tells us that the balloon is 0.485 miles above the ground. And if we want to convert that into feet, there's 5,280 feet in a mile. So 0.485 times 5,280. We're just under a half mile, 2,561 feet in the air.